Thank you for joining me. We got a situation developing actually right now. We just had a little bit of rain outside. Let me show you outside right now. My window. See the ground's a little bit wet there. It was actually a lone shower, an elevated shower that came through. The base of the clouds are around 15, 20,000 feet. There's actually snow coming down at the base, but because of clouds, even though the 32-degree line is basically right on top of us, it's in the upper 40s here at ground level, so it came down as rain. Even though they're not showing anything until the afternoon tomorrow, 15Z, we got a little bit of, like, very little. So here's what they're showing. So about half an inch of rain equivalent by about 5 a.m. tomorrow morning. I'll be leaving around 6 a.m. About this time, I'll be leaving to head towards northern Connecticut. Should be in the Torrington area because there's going to be several inches of snow there according to this run. I'm actually going to check which run is the best, but look at this. A very heavy-duty storm for eastern New England, especially central northern New England. Areas in the higher elevations could get a foot or more of snow. So this is looking at temperatures at 850 millibars. The GFS it's having an issue handling the dynamic cooling, evaporational, and dynamic cooling is basically a combination of evaporational cooling, which is when precipitation, when you have precipitation falling into a dry air mass, it cools down the temperature. It cools down the temperature and also raises the humidity. So as the air becomes saturated, the humidity, the dew point goes up, but the air temperature goes down, which raises the relative humidity until they hit a set point. So air temperature goes down, dew point goes up. Dew point is always lower than the air temperature. And that is why when you have thunderstorms, it cools down the air. That is also a form of dynamic cooling. But the GFS is not handling dynamic cooling very well. It never has. The GFS has always had a problem with dynamic cooling. It never handles it very well. So I can imagine that it's going to be a little bit colder on the west side, especially with all this cold air to the north. You're going to have cold air filtering into the storm from the north. You're going to have evaporational and dynamic cooling. Dynamic cooling, what I was talking about was evaporational cooling. We said that was evaporational cooling. Dynamic cooling is when the storm deepens, it pulls down cold air from the higher levels. I actually explain to you what dynamic cooling is. See? So you have evaporational cooling. So right here, this is what dynamic cooling is. Okay, dynamic cooling basically as an air partial rises, basically as air goes up, it cools and evaporates, cools and evaporates, cools and evaporates. Not evaporates. It cools and condenses, cools and condenses, cools and condenses, and this causes the air temperature to go down aloft. And then you have evaporational cooling and combined with that, which lowers the air temperature at ground level, and then the air temperature will go down with height as the storm intensifies and you have more precipitation. That's why sometimes you will have bright banding if you have an area of intense precipitation in cooler weather, as that is causing the air temperature to go down, which causes more snow to mix in, and sometimes it will even cause a complete changeover to snow. I mean, this is what happened. Yes. No, the precipitation doesn't actually drag down. Okay. Okay. It does not really drag down cold. Come on. However, if the precipitation is falling very heavily, two things are happening. Once you have a very strong upward motion, you get adiabatic expansion as you go to lower pressures, as the so you'll have less molecules bump into each other, and therefore you get cooling. At least that's what I think. Come on. Okay. Yep. So you have strong upward motion and heavy precipitation, which cools the atmosphere. So it's cooling across a vast area. Hey, Donna. So basically, I'm talking about how this computer model that I'm looking at is not handling the dynamic and evaporational cooling very well. The GFS is not. Even though they're calling for heavy snow, I think the GFS is maybe overdoing the precipitation, but also underdoing the dynamic cooling. Let's go to 700 millibars. That is where most snow forms, by the way. Okay, right here, you're going to have a lot of dynamic cooling. This is where you will have dynamic cooling, usually on the west side of the storm, or whatever you have heavy precipitation. So let's go up to 500 millibars, which is roughly 20,000 feet. Just a little, that's basically 5,000 meters. You will definitely have a lot of dynamic cooling. Definitely. Evaporational cooling as well. Because this is 20,000 feet, or just shy of 20,000 feet. This is 5,000 meters. Meters to feet. So 5,000 meters will be roughly around 19,500 feet, or just around 16,000 feet. Hmm. 5,700 meters. Okay, that's why I said 20,000 feet. 5,700 meters is roughly around 20,000 feet. Just rough, yeah. Or 18,700 feet. So it's just a little under 20,000 feet. And you're going to have very cold temperatures at altitude. So right now, there's several models that are coming in. You have another model. You have UK. You have the Canadian model as well. I already looked at the Canadian. Actually, the Canadian is right here. This is the Canadian right here. The Canadian is also implying that there's going to be a really strong system. So basically, the tighter the system is, the stronger the storm will be once it gets dragged up. This 500 millibar height will get dragged up the coast. So you want to look at its vorticity. Let's look at vorticity right here. So you have a lot of vorticity here. So that's going to be spin whenever you have blue. So the high vorticity values are going to be found here. So right now, there's an area of spin in the upper atmosphere. Yes, I am excited, Dale. It's nice that you joined. Right, so you have an area of very high vorticity, but this is all the way up there. This is at 20,000 feet almost. This is almost all the way up there at 20,000 feet. And models basically showing that the vorticity level will continue to wind up until it basically becomes this big nor'easter for the coast. The This run doesn't show as much snow. Usually the GFS does better with precipitation than this Canadian does. Usually the best model for precip usually is the GFS and the European. However, I do not have some weather model. So right here, this is the GFS trying to say, okay, there's going to be some dynamic cooling. However, keep in mind, okay, keep in mind, the GFS is not really doing very well with dynamic cooling. If you remember, in the middle of November, around November 2012, something very similar happened, and there was heavy snow in New York City with a very similar setup. Considering now it's December, you're going to have a similar setup. There's a potential of some very heavy snow. This is now 850 millibars. Again, not doing very well with dynamic cooling. NAM usually does better with that kind of stuff, but it doesn't handle precipitation very well. Sorry, that's 500 millibars. I'm home right now because I was in contact with somebody who had COVID. So again, this run is completely just shows nothing. Of course, the 6Z and the 12Z run were very impressive with storms. Okay. This run is also not doing very well with dynamic cooling either. That's why you want to look maybe up to 700 millibars, where it could be a little bit better. Right here, all right. You see how there's cold air wrapping in, especially here. So right here, there's a storm. Here you're having cold air wrapping. All right. The 18Z, the 6Z GFS was also NAM was very impressive with precipitation, just like the current GFS run is. Look at the NAM. Look what the 6Z NAM showed. Impressive. Showing a big heavy-duty snowfall, even in Long Island. Look what it's showing in Long Island. Like, of course, that could be it be trying to factor in dynamic cooling. Now let's look at the wrap. The wrap just came in. Of course, New York City is not going to get any snow. I could already say, New York City is going to get little to no snowfall from this. Maybe a little bit. I mean, here's the wrap trying to show a storm. It's trying to wind the storm up. What will determine how powerful the storm will be? Well, how strong the upper level low will be. So here's the storm. Here's that upper level low. And here's where the storm will form. The faster the jet streak is, the stronger the storm will be. Let's look at wind speed, especially in the upper jet stream. Wind speed. Not very fast. So let's look down to 500 millibars. Here's you're having those fast winds, which will enhance the vorticity. And, okay, if the deepening will happen further south, you'll have a stronger storm. Because I was looking at the 15Z run. The 15Z run had a more impressive system. Look where the 5400 line height happened. Well, right off the coast of Delmarva. So you had a much more powerful system here. Yet weaker and further north. So keep in mind, forms off of northern New Jersey, while this run formed it off of the Delmarva almost, basically. So you're going to have a big difference in strength. See, you have the storm further north, and this is the important part. You see this heavy bulk of precipitation? You have a 988 millibar low here. Here, you have a 990. So, still impressive, nevertheless. So let's look at 21Z. 21Z had the weakest of all. 5430, 5400. So basically, so you do have a stronger system here. I'm still waiting for the European to come in. It should just be coming in now. European should just be coming in. The first parts of the European should just be coming in. See, it's just coming in now. Let's look at the same time as yesterday, Thursday. So you had a pretty strong. Okay, let's look at regions. Continental United States, or Con-US. Or it says contiguous United States, if you want to say correctly, or continental. Okay, so let's look at Friday, basically. So we're looking at Thursday. Now let's look at right now. So not as tight. But let's look at the 12Z for Wednesday. So you have a 993 millibar low, a strengthening storm, thermodynamics. Also not doing very well with dynamic cooling. These models are not doing very well with dynamic cooling. That's what they need a lot of help with. Hold on. Dale, are you still there? I'm surprised you joined my stream. I didn't even advertise to you. Hold on. I'm just going to get my charger. My phone's down to 10%. And yeah, this is my school laptop. I have to return it. Hold on. Just got to get my charger. All right, got the charger. Alrighty, so I'm good. I'm in business now. I should also be NSFWX. He's a really good meteorologist. This guy right here. All right, especially his Twitch. Maybe y'all could watch his stream now. For every 2 Butterfinger bars you buy. Collect them all for the ultimate Halo experience. Only from Butterfinger.
Just saw those guys, bro. I thought it was up top. Alright, we'll take a look. Yeah, we'll take a look in a little bit. I'm gonna let it run and then we're gonna go over it. One of those guys looked fairly good.
Those 2 guys right there were good. For sure.
Yep. Yeah, he was talking about the model. Okay, I'm gonna let it run. So, okay, let's look at the current.
The second, I think I dropped the second guy. I think you dropped
95. See, very close. Like
laid down a fucking pipe on that first guy with the fucking 800. Wasted fucking more money and ammo on his whole kit.
I did, for sure.
I'm full on that.
we're still at 0. 1007.
Day rates are just fucking like just another like level of like night rates we could run around like bullshit, whatever. It's just easy mode kind of.
Yeah.
Sometimes. Day
I'm
rates.
just gonna mute it for a second. All right. So I'm planning on going to Bethlehem, Connecticut, since it's almost 1,000 feet above sea level. I want to see the snow. So, and this is definitely going to be with elevation. You're going to see more snow. So I'm probably going to be leaving 6 a.m. Saturday morning because I want to be in Bethlehem, Connecticut by late morning, just about when the storm should be like starting to intensify. I want to be there by maybe 16Z. That's when I want to be in Connecticut before 18Z, because that's 18Z is when the heaviest of the snow is going to set in. GFS is saying is going to be faster. I mean, the NAM saying is going to be faster. However, the GFS I might try to leave a little earlier because, okay, they're saying that the worst of the storm is going to be right about when I'm going to be leaving. So I might leave maybe at 5 a.m. Just need to look at the train schedule. Um, hard at Saturday. Hmm. 9:58 a.m. Okay, if I get there by 10 a.m., that'll be about. Okay, I'm trying to figure out the Zulu time. Okay, if I leave at around 6 a.m. here, should be on the New Haven train, should be then in Waterbury, Connecticut by 10 a.m., which would be around 14Z. Can I donate sometime? Oh, you don't have to, GamerX. You know that I really appreciate that. I mean, hey, I mean, you, gamer, you should be taking care of yourself because right now I'm the only thing I'm using money for right now is to pay for my college, which I really need. But I don't want you to be giving me money. You've been through a lot, and I really think you should be focusing more on yourself. I really appreciate the gesture, though. And, all right. So to Waterbury, Connecticut. So the train to Waterbury is only 6 stops. You know, honestly, I wish America was more like Canada with free healthcare. I mean, I have free healthcare, but there's a lot of people who need it here. Especially free education. It's really expensive. Come on. Alrighty, let's see. The GFS again is having a hard time with the dynamic cooling. Let's see if the European has come in. Um, Showing 1,009 uh, uh, low over North Carolina, right around the North Carolina south. Um, so okay, let's see. European is only starting to come out now. Like it's only starting to come out. But there's definitely a good amount of no, I have OBS. It's on my PC, which is on my campus. I had to come home because I had to help my grandfather, but then I was exposed to COVID. So now that I'm cleared, I'm gonna go back to campus probably a Sunday. So I don't have COVID. I'm gonna have to monitor my symptoms, and I'm gonna get tested in a couple more days. I'm probably on Friday or just tomorrow. I'm gonna get tested again. Dale, are you still there? Wait, my allergies are coming in. Ugh. Thanks, gamer. Had to check on something. Let's see. Okay. Now that the 48 is back, I'm gonna make an assumption, and it's probably gonna be a fundy right about here, and it's gonna be a lot weaker, probably in the high 980s. Oh wow. Okay, 984. That's definitely gonna be quite a bit of snow for Boston. Let's see what this guy's saying. So unmute it.
The overall 500 millibar looks a little slightly west. It'll probably end up being very, very similar. Right off Boston. I'm not out that far on weather belt. Oh, I see it now. Yeah, it's out a little bit further. Yeah, it's going to be hard to tell. I think the Euro's probably on the right track. The thing that's just going to kill people is that sharp ass cutoff, super sharp cutoff. I like running the hollow side for short. I just feel like not having
Yeah, they have a site on this,
It's just that's just not a lot for fun. I wouldn't pay attention to football goals and shit unless the only time you really need to like worry about that is if you see like anything significant. Run to run ships by 3 to 6 inches or whatever is not that big a deal. I use weather. For the Europe? Yeah, but doesn't it only do like intervals of like 60 frames or something?
Yeah, basically we're gonna get a big storm.
Every 24, yeah. Oh man, parts of like Boston and shit are gonna get like a foot and a half of fucking snow on Saturday.
Really?
Everyone's gonna get fucking water. I just love it, like when I kill people or like kill you guys on like I'm not
Mm-mm.
we really got away from playing other maps. We don't know woods no more. We don't fun.
Yeah, dude.
We just hammer cousins.
Shoreline, I feel like it's just so fucking like it's so big and boring. You don't. It's like an.
The shoreline is alright.
You gotta get there though. You gotta go there. You gotta get.
All of shoreline is just whoever gets in the fucking east wing first and then waits for people to come running in. So like the whole fucking map. I would say probably, for Boston, they're relative to 500 again. I haven't looked at any of the snow total maps, but they're both, in my opinion, probably relatively similar.
I think the lab's next to me.
I think anything like from central Mass to the coast, with the exception of like Cape Cod, because they'll probably still be mostly rain, is probably looking at like 6 to 12. I would be very wary on some of those like monster totals until you start getting like up into like southeastern Maine. Once you get into like southeastern Maine, you're probably talking about 12 to 18. And obviously there's going to be some isolated pockets of heavier snow, but the ratios aren't going to be that great. If this was January, a lot of this would be 1 to 2 feet on a system like